Good afternoon. Yep, up here in front. Good afternoon. Hello? No one?
Hello.
Hey, so good. So someone listens to me. Thanks, Bruno. So this is the spring working group meeting. Today is Thursday. It's a beautiful afternoon here in Madrid. I hope you're all doing well. Yes, everyone's doing fine. Great. Thank you. Wow, no feedback. This is a good time to remind everyone that we need working group engagement for everything, including when the chairs say hello. Hello? Okay, great. Oh yeah, wrong language. Hola. We can do a little Spanish class before we start. So I'm Álvaro in Spanish, right? So Bruno and Joel are online. And we're ready to start the meeting. Peter, no, he didn't hear me. I was going to say, if someone can close the door as they come in, that would be great. Okay, so as I said, this is the spring working group meeting. Bruno and Joel are online. I'm Alvaro. We're going to start. You all have seen this already, but please look at it again. The note well talks about the code of conduct. It talks about the policies of the IETF around participation and contribution. There are a bunch of documents, including the standards process, anti-harassment policies, code of conduct, privacy policies, etc., linked at the bottom there. Please take a look. If you have any questions about them, contact a friendly chair, your AD, anyone you want to talk about that. The idea of this is to create an environment in the IETF where we can all participate and where we can be treated with dignity, decency, and respect. So please make this a practice here and everywhere else in the IETF. If you haven't already, please log into Miraco. You can scan the QR code in the back. You can click on the agenda so that we can keep track of who's here. I see right now 40 people logged into the meeting. The minutes are a collaboration of the working group, just like everything else that we do. Shuping, who's sitting over here, our secretary, does a great job always in taking notes, but please help her check that we're capturing what you said, maybe double check your name, etc. So let's talk about where the working group is right now. We published a new ROC 9800. This is a compressed SID list, compressed service sets. Thank you for everyone who worked on this. It was a long journey, but a fruitful journey. So thank you to the authors, the shepherds, everyone who reviewed it and commented on this. We are close to sending another document to the IESG. Working group last call already passed for this. We have a shepherd write-up. Liu Yao has been really good in providing comments as shepherd of the document as well. They have been revised. We're now waiting for the Routing Directorate review so we can forward it to the IESG. We want to highlight two hot topics. Hot, not in the sense that they're contentious or anything, but in the sense that they're important. And we want you to please pay attention. We have been working, and all of you know this, or should know this already, we have been working on SRv6 security considerations. This was requested by the IESG as something really important, so we have been prioritizing the work. We are going to have a discussion today about the latest draft. We have had a discussion at every IETF since the last few ones, and had an interim several weeks ago. We are considering another interim before the next IETF. Please review the draft, participate in the discussion, make comments. We are making progress. We hope to be able to working group last call this document by the end of the year. So hopefully before the next meeting, as I said, we're going to have another interim. And ideally, in the next meeting, all we need to do is discuss any open items and close them, and that's it. Who has not read this draft? Oh, everyone has read it. Somehow I don't believe that, but you know, there's no reason I shouldn't trust everyone. So great. Please send your comments to the authors. The other thing that I want to point out here is we got a request from the IDR chairs for us to do an in-depth review of the IDRSR policy extensions for NRP, for the Network Resource Partition. IDR is already a little bit advanced on this draft. Please take a look. You can click on that link there. It takes you to the mail archive. This draft has a normative dependency on that individual draft that we have there. It is an individual Spring draft. So one of the opinions that IDR is looking for is whether this should be a normative dependency or not. Independent of that, this is an important topic that has come up before between IDR and Spring and other places that are working on NRP. So today, we actually don't have a discussion on this topic, but we are also considering an interim focused on that, on the topic of SR and NRP. So if you have drafts on that, or you want to participate in the discussion, please look out for the announcement of the interim. Now, I mentioned two interims, one on security and one on this topic of SR and NRP. We haven't figured out when, but I'm going to throw out here probably by the end of August and maybe by the end of September, we'll have the two interims. So please be on the lookout on when we have them. Please suggest drafts for this topic and participate in the security review as well. Safari, you have a question?
Yeah. I don't think we can.
Can you say your name?
Zafar Ali from Cisco. I don't think we can just progress this work for SR in isolation because there are other pieces and dependencies. Just a comment.
Thank you. Come to the interim. I mean, we're not polling right now, advancing anything. We're just, showing this up there. So please come to the interim and make sure that not just you, but everyone reads the drafts. Just like everyone read the security draft, everyone should read all the other drafts as well. Okay. So before every IETF, we ask all the document authors for all the authors of working group documents to give us an update. This is the update that we got. As you see, there are many empty spaces in there. If you are an author of a working group draft, please give us some feedback once in a while. There are a couple of expired drafts that show up here. Some of them are in progress. For example, the first one, the BFD draft, which we had already working group last called. I had a conversation with Greg this week. He is working on an update, so we should see an update relatively soon. There are several drafts in here that this is the update that you gave us, that you marked as, for example, ready for working group last call. We have been advancing the DHCP draft. There we have a shepherd. We're just waiting for reviews from him and for him to tell us that we're ready to go. On that, resource-aware segments, we're in a similar situation. The shepherd, who happens to be me, did a review. We're waiting for an update and an implementation section. Good time to remind everyone that all Spring drafts require an implementation section as per the working group policies. Enhanced VPN, we said we would wait for resource-aware segment before we look at that one. Bruno sent a review for the SRV6 path segment, so be on the lookout for that. And the other one that's marked there is ready for working West call is the stamp SRMP draft at the very end. There is a presentation today about that one. This is the agenda for today. Does anyone want to change anything? I am required to ask that, not that we would change anything, but you know. Okay, so we're ready for the first presentation. So Nick, I haven't seen him. Oh, there you are.
I like to sit in the very back.
Yeah, you're hiding. So if you heard, I asked who had not read the security draft. So we're very happy. Feel free to ask anyone any specific questions about the
Very
draft.
detailed questions
Very
to come
detailed,
of
yes.
the audience. All right. So this is, like it says on the slide, the 123 update for the SRV6 security considerations draft. Do you have a clicker? Or you want to do it? All right. So as folks may well know, we have a schedule of deliverables that we've been working against. From the July and the interim, we were working on the control plane threat model, including attacks and mitigation. That was due for this meeting. We completed that as well as a bit of a rewrite that split the control and the management plane apart. And in doing that, we created a new structure for each section that has attack, oh, there's a misspelling on there, attack, scope, and effect. And so the control plane attack section, it better defines the relationship with routing and the control plane attack context. It also breaks out the mitigation section, as I said earlier. We also, as a stretch goal, managed to get, because we broke these apart, we were able to sort of start working on the management plane as well. So that's actually, we're a little bit ahead of the game on that. It was scheduled for November. It uses the new structure, and it adds some details regarding a centralized controller as an attack vector, which was in there a little bit, but it wasn't very clear. That's now better defined, I think. Although I guess I could ask the audience for details on how, if that's better defined, since everybody's read it. That was a joke. That's a joke. It's a bad joke. Okay. So anyway, we completed the rework attack summary table as well. That was requested, I think, maybe 2 IETFs ago. So that's, I think, a little bit easier to understand and read. And that's it for this session. So what are the next steps? If anybody has suggestions for what we should add in addition to finishing the management plane, I would love to know that. You can send it to the authors on the list. You can tell me here, and I'll go back and check the notes. And yeah, what else?
From your reading of the draft, anyone has any questions, comments? I have a question for you, for them, but for you.
Okay.
It was not clear to me still.
I'm sorry.
It's not clear to me still in the draft, the difference between what are you considering to be in scope for the control plane and what do you consider in scope for the management plane? Because in the section number 6.3, where you talk about control plane attacks, you actually define in there and talk about the fact that you talk about OAM as well, apparently in that section. So I think that's something that we need to clarify well, right? You know, what are we considering in scope here and what are we considering in scope?
Okay, so better clarification and probably also in management plane, just to make sure they're consistent.
Correct.
Okay.
Yeah, hi. This is Dhruv. Regarding the control plane part, I think we have added PCCC, which is very good because, of course, it's a much bigger attack vector compared to normal PCE when you are just talking to the head end. But we should still capture that as well. Like just using vanilla PCE, we are only talking to the head end, configuring an SR policy, and via configuring that SR policy, I can also do some reroutes. Same is true with BGP as well. And in fact, that is not captured at all. So
The
there
upgrade
is still some work that we need to figure out in the control plane, but it's going in a good direction. So thanks for doing work. Uh, Once that's ready, at some point we should also reach out to other working groups, especially in the control plane side, that look, this is the section that we have adding. Make sure it's consistent with what's there in the protocols as well. Thank you.
Great comment. Thank you.
Anyone else? So, as I said, we're getting ready, or we hope we're ready for, as Nick pointed out there, for the final discussion at the next IETF. Hopefully, we can do it before that. That's why we're going to have an interim, as I said, sometime probably at the end of August. Since we're close, I want to call for volunteers to be the shepherd for this work. So far? Okay, great, perfect. Great, so we're gonna have a discussion later to tell you all the work you have to do. Thank you so much.
Awesome.
Thanks, Nick.
Thanks for the input, everyone.
Okay, Rakesh, we're going to talk about STAMP now.
Good afternoon, everyone. My name is Rakesh Gandhi from Cisco Systems. I'm going to present an update on the performance measurement using STAMP for SR networks on behalf of my co-authors. So basically, draft defines various measurement modes in SR networks, one-way, two-way, loopback, and loopback with network programming, and STAMP encapsulations for these modes in SR networks, including links, transports, services, L2, L3 services for both SR-MPLS as well as SRv6 data planes. And the goal is to get better scale and convergence, so to optimize the STAMP processing on session reflector. And again, it's all using STAMP. So the first one, one-way measurement mode, the packets are transmitted with the same encapsulation as the traffic that we're monitoring for the path, the SR path flex algo or services, but the state reflector will not reply back to the sender, and we get the one-way delay that's computed by the stateful reflector. So in case of a two-way measurement mode, packet is punted and re-injected on the reflector, so that slows it down. Again, using the same kind of encapsulation and SR return path TLV. Now we get the round trip delay as well as one-way delay. And then there is a third mode introduced in SR for loopback measurement mode. In this case, there is no punt and inject on the reflector, but packet is just forwarded in the data plane. But we get the loopback delay only. So we introduced the fourth measurement mode, loopback mode with network programming. In this case, network programming function allows us to capture the received timestamp T2 on the reflector using network programming functions, for example, SRv6 endpoint, or in case of MPLS, MNA opcode. And now we have one-way delay as well as loopback delay. So examples of encapsulation, this is monitoring the segment list of SR policy or SR IGB flex algo path, L2 VPN service, L2 VPN service, using the same encapsulation and seeds that's used by the traffic. Similarly, for SRv6, also similar kind of encapsulation that's used by the traffic. There are two encoding modes defined for SRv6. One is encaps mode that has inner IP header, and it's been optimized in insert mode with no inner IP header, and there are different pros and cons of each model. So next step, many thanks for the review comments from Gyan, Boris, Greg, Zafar, Rudiger, Lian, Zhengchuan. Welcome additional comments. We have updated the document. We do have two requests at this point from the chairs and working group. One is that the document is quite long, so we hope to split into two documents, one for each data plane. So we can move SRv6 faster. There is M&A work happening in MPLS working group, but a bit slow. And we do believe the document is ready for working group last call.
Diego.
Thank you.
Diego from Nokia. I just wanted to express support for the idea of splitting the document, one for SRMPLS and one for SRv6. Thank you.
Thank you.
Maria from BERT, I'd like to ask you whether it would be possible to distill what is actually being measured to a separate section of the document, because when trying to read the document from beginning to end, I was very confused what is actually about. Thank you.
Okay. Yeah, there is a section on loss and latency, but we will add a section to explicitly say what are the metrics with the latency and loss being measured. Yeah, good comment. Thanks.
So you have for SRMPLS dependencies on MNA because you are doing it using the MNA label stack, right?
Yeah.
Can it not be done without that? Just using native SRMPLS?
So there is in this particular mode, there is network programming function to capture the received timestamp in the data plane. And one way to do it is in M&A. There might be other ways to do it, but the document talks about M&A because that's the work MPLS working group is working on.
Okay.
Yeah, thanks.
Before you sit down, Himanshu, did that convince you that it's okay to split the document?
I would like not to have to support the MNA. Just keep it in SRMPLS native mode. But if there is no way to induct the packets at the intermediate hops using SRMPLS, is that the reason why you are using the MNA? Or you just want to use one common format so it can be used for SRMPLS as well as in MNA?
So the M&A allows the network programming.
Yeah.
It's only used by the endpoint node. On the reflector only, it's only one node, not any midpoint nodes.
Oh, okay. Then you can do it with the SRMPLS, right? I think in your one of your slide you show that the packet is punted to the control plane, right?
Yeah, so in this mode, so that it's punted on the reflector and re-injected, but its bit scale is lower because it goes to the CPU and come back. And if you want to improve the scale, so that's one way to do it using forwarding in the data plane and capturing the received timestamp.
But I suppose you can do that using the return binding seed or something like that using the SRMPLS.
Yeah, so look back more, you can do it, but then you don't get the T2. You need something
If
on
I may,
the vector to
I
get
may,
the.
Rakesh, I think that the question of which encoding should be used probably needs consultation with the MPLS working group. The Spring working group shouldn't be choosing whether to use MNA or not. And that's a question, but I don't think it's a question for the Spring working group to resolve on its own.
But I rather not. I mean, I would rather prefer that you don't have to use the implement MNA.
And Manshu, what I'm saying is the place for that debate is the MPLS working group. It's not up to Spring to have a preference on MPLS data encodings.
Either way, I think if you can have an alternate way to do it, then that would be good.
Yeah, one way to do it is split the document and then work on the SRMPLS part, maybe. Okay. Boris.
Boris, MWS. Rakesh, shouldn't we update implementation section to include this open source stamp client, which was just announced?
Good point. Yeah, so there is open source implementation available in T-Party for stamp as well as the written part TLV that's being used. And good point, we will add it.
Thank you.
So for release system, I think I support the authors for this proposal for splitting because as an implementer of like if you're doing a service implementation, the document is too long, and you get the information that you need if the document is splitted. And then based on what Himanshu also mentioned is there's another reason what Himanshu was discussing. Then we can have that discussion in that context of the MPLS. Thank you.
Thanks, Appa.
Yeah, we Chang from China Mobile. I also support split the draft, and I think SRv6 part is mature and it's useful. We should let it go at first. Yeah.
Yeah, thanks, Wei-Chang.
One comment on one question. One comment on the INI section of the draft. I believe you are defining 2 code points, one for SRMPLS, one for SRv6. But the INI section says nothing.
Yes, yeah, I
It's
support
long.
that. Yeah.
So Bruno, this is using the code points from the vendor specific or the private use case, which is not advertised into IGP. But if there is an interest, we could define the standard code point as well. So if there is a feedback, we can update the draft based on it. It's an informational draft as well. So it may become a standard track if you are asking for code points from the standard track INA.
Well, for SRv6, it's first come, first serve, I believe. So you can get one.
Ah, okay, okay.
And for MPLS, MNA, well, I don't know.
Okay, so that's another reason to split it and progress it differently. But yeah, we will add the INA section for the SRv6 endpoint if it's first come, first serve.
Thank you. And the question is, if you split, some sections are clearly data plane specific, so it's easy. Some sections cover both data plane, so you need to split on a per sentence basis. On some sections seems to be agnostic. So what are your plans? You would duplicate all the sections which are agnostic, or how do you want to do the split?
So the definitions of the measurement modes are agnostic, and encoding or the encapsulation is different for different data plane. So if you do split it, what will be repeated is the measurement modes into documents, but the encodings obviously is data plane dependent.
Okay. Don't you fear that we have a lot of text which is duplicated and we will need double the time for review and details, and maybe inconsistency if you progress at a different time, which is your plan, I believe?
Yeah, if it has same set of authors, then yeah, authors can ensure the consistency between the two documents.
Okay, thank you.
I don't know if this is what Bruno's getting to, but maybe you can also reference the definitions, right, from one to the other.
Yeah, so if SRv6 is done, then SRMPLS can use that. It's the more defined in SRv6, and then we don't have to duplicate all the text.
Right, exactly.
Yeah. Okay.
And that way, not only from the author point of view consistency, but the reviewers, not just working with, but others may have different opinions at different times, right?
Okay. Yeah.
So I got several things out of this. One is there seems to be support here on splitting in general. We'll take it to the list anyways. The other one is the point that there should be some consultation with MPLS. And there was a third point that I forgot. There's something else. I'll remember later and send it out to the list.
Okay. Thank you.
Thank you. Okay, so now we are going to talk about Yang.
Hello, everyone. My name is Kamran. On behalf of other authors, I'm presenting 2 Yang drafts, an update on those drafts. One is SRv6 Yang, and other is SR policy. It has been a while. We have given an update. So it's a little bit loaded slides, but I'll walk through quick. So a quick overview and reminder that SRv6 Yang actually has two Yang models. It is base model for the building blocks, and it's a static model for static sets. And the focus of that Yang was, and focus and scope of that Yang was the base SRv6 network programming RFC, SRH RFC, and the compressed RFC 9800 that used to be a draft before. In terms of history, a quick recap and reminder, it was last presented a long time ago at IETF 106, and it was adopted a couple of IETFs later. We have made several intermittent updates since then. The main changes on those updates have been about aligning, keep it aligned with ongoing RFC, progression of network programming and SRH, as well as then we added CSID and SID structure related changes in the latest draft. So latest draft has been published just before the IETF as a working group version 5. So far, we don't have any Yang formal doctor reviews by Yang doctors, but we're looking forward to a request one. Very quickly, so it has 3 modules, types, base, and service static. Today's focus is not really service static because we are trying to propose also a split of this document into two separate document, one for the building blocks, which is a service base, and other for a service static. And a service static document has not progressed, as fast as we wanted. So we are going to just focus on first 2 modules for a quick update. So as a quick reminder, for the types module, we are addressing and defining all the types, base types that a service needs, locator related attributes, SID and SID related attributes, SID structure, compression, different identities for different type of compressions, and base RFC 8986 and 8754 related types and security and the counter rules in the types module. In the base module is a fundamental model which augments segment routing path, and it defines all the construct, which is configuration, state, and the notification to manage the SRv6 system. Very quick highlight. So in terms of configuration, the very high level, the module allows you to enable SRv6 because by default it's disabled. The encapsulation related parameters you can configure. There's SID formats related structure you can configure specifically with compressed in the picture. There are specific fine tuning that vendors may need. So this has been recent changes to the draft to introduce SID format or SID structure related fine tuning. And the locator has been there for a long time to configure locator and different attribute related to the locator, as well as minor changes in the SID configuration. Operation model goes along with this. Only new thing in the different thing that operation model has is some of the node capabilities that you learn from your neighbors, your own capabilities as well. You can learn from your neighbors, as well as showing the some of the operational state of these building blocks that are in the config model. It also supports a notification in terms of locator operational state or the SID allocation collisions. Static model is not a focus, so I'm just going to skip, but just going to remind that static model is literally a configuration model. Operational state and notification already come from a services base. It is a way to configure local SID or instantiate a local SID statically. So that's what a static model is. I'm going to skip this. So in terms of the open items, the pending items for SRv6 Yang, in the types Yang module, there'll be offline comment from Yingxing and others that I think it's better to use IANA maintained module for SRv6 endpoint types rather than our own identity. So we're gonna make those changes in the next revision. There'll also and maybe we'll look at other types that may also could be moved same way. For the base .yang module, we still have few changes to be addressed, which is related to replace SID, and we are working among the authors to make those changes. For the static, we need to extend static to bring compressed into that model, and we have to look at some of the other pending items. So what we are asking as a next step, and ask that, of course, any feedback is most welcome. Has been a while that we have presented this work. We want to do drive to completion, and for the faster progression for the SRv6 base, as well as the document is already 100+ pages. So we are proposing from the author side that we should perhaps split this document into 2. services-based Yang data model being one document, which is more advanced and mature and close to completion, and let a service static be in a separate document, and it does require some work to make it through the progression. So that's one open question and comment for the working group. We'll want to address the open items in the base module to progress it faster, and also request the early review for the Yang actors to fine-tune our Yang modeling. So that's about for this update. Any question?
Comments, questions, opinions?
Justin Suran Media, since we published 9800, let's align names for compressed with ZRFC.
Sorry, can you come one time?
We've published 9800, the compressed ZRFC. It uses somewhat different naming conventions than the Yang draft.
Sure.
Let's align them.
Sure, we'll align with this. Okay, thank you.
Dhruv, regarding 9800, one more question: that should we use features or not? And that's a question maybe for the working group as well. Are we in the state that no, everybody's going to do compression, it should always be there, or is it something optional in the Yang where your base is there and you have to explicitly enable compressed? That's something I would want us to think a little bit about as well.
We can think and discuss this more. But right now, it is not under.
Yes, I know it isn't, but that's something. What you consider as a base and what you consider as an optional feature is worth to think early on, and it should be consistent in our documents and in our Yang models.
Typically, in the past, for the feature we have done with a specific feature, this is more like a two data plane, but definitely we can discuss.
That's why I'm not giving you the answer. I'm just asking you to think about it. And the INA part, I completely agree. It has to be, because that's the first thing I saw. It's first come, first serve. So you can't even wait for our documents to get updated. They are just going to get updated at INA automatically. So this one has to be an INA maintained model, at least the endpoint behaviors.
Absolutely.
Apart from that, thanks for making progress, but keep the momentum. Let's push it out.
Thank you. Don't sit down. Let me ask you a question, Ruud. So I know that in PCE, there's at least one draft that depends on this one. To that question of splitting the drafts, I'm assuming your dependency is on the base.
My dependency on types.
Yeah, base and types. Yeah.
And to be frank, in Yang, I don't go by page count. It doesn't matter. It's easier, in fact, for a reviewer to review everything in one shot, but it's up to you and the working group to figure out. I don't have a strong opinion on that. Like splitting because it's a 100-page document, that's not the argument.
Yeah.
If it's stopping your work and you have further, then...
As I mentioned, the strategy is way behind in terms of to catch up, whereas a service is base, which is types plus the base building blocks, they are well matured and we just got close to completion. That's one of the reasons too.
Anyone else? Okay, I don't see any real support or opposition for splitting the draft. So we'll take it to the list and figure it out there.
Yeah, thank you.
Yep. So we still have you for another exciting Yang presentation.
Okay, so this is second draft, just following similar timeline and trajectory. It's SR policy Yang. On behalf of my authors, right, I'm presenting this work. It's a Yang model for SR traffic engineering policies. It's aligned with the SR policy RFC, architecture RFC 9256. It's generic and applies to both SR data plane, MPLS, and SRv6. And it defines policy state, config, and notification in the model. Just like SRv6 Yang, last presented IETF 106, adopted since then, and a couple of IETFs later. We have made intermittent updates since then, mainly to keep aligning with the SR policy architecture document, add new types, based on some of the offline input and, working group input, added few more things which are missing. And last update was just pushed before the IETF, and we don't have any formal reviews from the Yang doctors for this Yang as well. So I have lots of slides, but I'll skim very quick and only focus on a couple important one. So just to recap, this Yang model has types and the SR policy. So, and it conforms to an NMDA just like SRv6 Yang. In the types, these are all SR policy specific types, that are needed in the modeling. It has types for state as well as reasons for different things happening. But the configuration in terms of hierarchy, the model literally has kind of three areas. One is to configure and manage policies. Other is to define an attributes, which are mostly the traffic engineering attribute, because this model because this model is augmenting segment routing and it's a traffic engineering tree. So we have an attribute for TE, and then we have also optimization template that relates to ODN policies. So this is how it's kind of arranged. If I were to double click on some of this bit more. So for policies, we have policies. Within policies, we have a candidate paths. A policy has a binding set and other attributes. There are candidate paths, and candidate path could be three types. They could be like explicit, dynamic, or composite. In terms of attribute, currently only attribute that we see as common T attribute that is defined is the segment list, which could be used in SR policies or could be used outside SR policies as a general building block. Optimization templates are defined specifically for for the color specific templates that could be used for ODN policies or for some other use cases. Moving on. Okay, so policy set covers both binding set for MPLS or SRv6. So you can have both. In SRv6, you will notice there's more than one binding set because SRv6 can have different behaviors, and you can literally have more than one binding set for the policy. For the candidate path, the key attributes are all there. But in terms of the candidate path types, the explicit candidate path is basically a set of weighted segment list that you can provide. And segment list is nothing but a reference to the segment list that is already in the main attribute container. And segment list follow the segments of the segment list follow the RFC 9256 architecture, the types that are defined there. Dynamic candidate path is more interesting as well. It has optimization objectives and constraints. We have defined our own, but this has been feedback in the past, and I think recent feedback as well. We could use some of the existing. We should use the existing grouping from TE and use it here. So authors will be working on this before we progress this work further. Composite candidate path was also required as per policy architecture. So composite candidate path is also part of this model. And we have a bunch of forwarding state. For ODN templates or optimization templates, model also defines as a, in terms of a candidate path related to optimization template per color that an ODN policy or any other use case can use. The subtree of that candidate path follows same optimization objective or constraint what I have just mentioned in the previous candidate path discussion. Policy also has notifications for policy events as well as binding state related events and few other things. If there's anything that's significantly missing, we'd love to get the comments on notifications. Next step, we wanted to cross-check and address any remaining gaps based on the feedback that we received on few things already during IETF and in this call on this session. We are going to address those, and then we'll request an early Young Doctor review, and any feedback is welcome.
Thanks. Can you go to slide number 8, please? This is Dhruv. I think the one big confusion from the very beginning that hasn't been addressed is this only for device model, or can I use this SR policy model on a controller as well? I would assume I should be able to use it on a controller, but I want to hear from you as well.
I think it's supposed to cover both.
So then it's a very basic request that from SR policy, let's put a head end as one of the key. Unless we do that, this model I cannot use.
Yeah, we had that discussion before, so definitely we'll discuss more. And
yeah, please, let's handle that. Thank you.
Thank you, Dhruv.
And regarding the T's thing, I think, yes, please reuse. Let's not redefine constraints. It will also allow us that as T's update, the same thing can be reused. We don't have to update our stuff as well. So consistency, please. Thank you.
Thank you.
Himanshu from Siena. You may have already talked to Amal. There is another flag that is coming about, eligibility attribute for the candidate path. So we may ask you to add that in.
Okay.
Okay.
Thank you.
There is a presentation today about that.
Okay, I'll catch up offline and happy to discuss this.
Boris again. Basically the same question, but maybe Alvaro, maybe in more general way. So like, should we like stop any activities here for the model and wait while any other proposals for modification of SR policies will be like handled, like how we should proceed?
Yeah, that's a really good question, because specific to eligibility, it seems to be a concept that the working group likes, but the draft's still an individual draft. So anything that goes into a Yang model has normative dependencies on all the drafts. So what that means is that when we push the model out, we would have to wait for all the drafts to be published as well. Now, on one hand, sorry to be blunt, we have been working on this for a long time, so maybe waiting a little bit more is not a big deal. On the other hand, we also want to be as expedient as we can. Do you depend on this draft too? Okay. 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 So yes, let's please discuss this on the list. You know, what kind of things we want to add or not. And what I want to ask everyone in the working group is to take a look at the module. We're going to have a Yang review, but take a look to make sure that the features or functionality or whatever that you want are in there. Especially with everything that has already been either published or that is a working group document, right? So let's give priority to that. And as we keep going and the work keeps progressing, hopefully all the work, then we can figure out the specifics of things. Yes.
Thank you.
Thank you.
Yeah. Thank you.
Okay, thank you. So now, and thank you everyone for the discussion. Again, working group engagement is the most important thing. All the work that we've seen until now has been working group adopted, working group documents, and the remaining drafts are not working group documents yet. Please also read them, pay attention, comment, and engage in the working group. So far.
Thank you. My name is Zafar Ali. I'm going to present this SRV6 policy set list optimization draft on behalf of my co-authors. So what is the problem? So this is SRV6 specific. So SRV6, when a policy takes traffic from head end to an endpoint. When an endpoint identified by the endpoint node locator. But when the policy is carrying service or some other ways where the traffic is already going to the endpoint, and one example is that the policy SID list is carrying it to service is carrying the policy to the endpoint. At that time, having endpoint SID in the data plane makes the two SIDs that are local to the node, to the endpoint node, back to back. And this is not efficient for compression and for MTU point of view. There are service SID is one example of such a case. The binding SID another example that I'm taking policies, and the endpoint is the head end of a binding SID. Same applies to EP SID. But it is not possible that is always the case that, for example, is in MPLS interworking, such exclusion is not possible. So we started the work in 2 IETF back. For better or worse, we started with PCE and BGP changes. These changes were discussed and presented, in PC and IDR working groups, and specific comments were made, mostly for encoding, not on the base, not need or. I think there was a general agreement that yes, this problem statement is correct, and but there was some comments on specific encoding related that we went ahead and we addressed in the IETF 122. We presented again the drafts on IDR and PC working groups. There was a feedback received during that time is that it would be good to have a Spring draft that glues these pieces together, and Spring is fully aware of that, and that's why we wrote this draft. But the work has been progressing for the last two IETF. So that's what the history. So what a draft does. So basically, it is a high-level draft that glues the pieces together. So it allows an sRPC API to control the inclusion or exclusion of endpoint node SID depending on what type of traffic is steered over it. It describes procedures for SR policies from various sources. So these sources include PSAP and BGP. It also includes BGPLS, like a glue for like need for advertisement in BGPLS for this list optimization if it has been exercised when installing a policy or not. It does talk about some MSD consideration, because naturally if the endpoint node sits, if you have opportunity to exclude the endpoint node SID, then you can consider an additional MSD when computing or when installing the path. So you can go one SID extra. So that's those kind of discussion happens here in this draft. And then it also describes some O&M consideration that I will go over. So for the section on policy creation using PSAP, PCE itself always compute the route to the endpoint. This is path compute. This is not related with path compute. So path always takes it to the endpoint. There is a need for PCC and PCE to exchange capability for backward compatibility reasons. And if and only if the both ends of PSAP peers are capable of supporting the endpoint node SID suppression, the PCE messages or signaling carries a flag. So it's really a simple flag, which is called ENS flag. And it's been consistent across the way this is done for PSAP and BGP. Everything is consistent. And this is why we are also in Spring to maintain that consistency across different pieces. Okay. So, and the protocol extensions are defined, are available in the reference provided. And this is on the PSAP, PCE working group agenda tomorrow. The solution applies to both PCE initiated and PCC initiated. And there are specific MSD considerations that I went over that are also specifically discussed in terms of the behavior. And then there is a counterpart in IDR that actually talks about same notion that when there is an opportunity for doing endpoint node suppression, we just use the similar kind of flag mechanism. So again, ENS flag, consistent mechanism. So it doesn't depend on which API is used for programming. Everything is consistent. It's just the protocol mechanics that are different, and those protocol mechanics are being reviewed with the individual working groups. So the draft in question here is mentioned as well, and this was, like I mentioned, was presented in previous times. Then if a node has installed a SID list with exclusion, so it excluded the node point endpoint node SID, then there are certain extensions defined in the BGPLS so that the node can tell or advertise that this is how it has programmed that particular SID. This is again uses the consistent terminology, ENS flag, and it's a single flag in question. From an O&M point of view, this is really about when we carry services or data traffic, and depending on what type of traffic is a steered over policy. But it does not apply to the cases when we are generating probes, because probes are to the endpoint, so we don't suppress. The probes are generated locally. So if we are doing any local generation of the probe, I mean, obviously we need to carry it to the endpoint so the endpoint can respond back to this. So it's just drafts say the obvious in terms of the O&M consideration. There was a specific comment, and we addressed that comment. So I think at this point we feel that because we've been discussing this in for last 2 IETF, not here but other. We feel that this we would like to working group adoption. We feel that there has been reviews on the overall work.
Greg, go ahead.
Oh, I'm first, thank you. Yes, Greg Mirsky, Ericsson. So if their encapsulation, so if seed list is different for the data packet and active OEM, as I understand it, how to ensure that OEM packets will receive the same treatment and will follow the same topology as data packets. So how then we ensure that we receive useful observation information?
Thank you, Greg. Good question. So see, the locator for the endpoint does not change whether you are carrying a service traffic to it or you're carrying O&M traffic to it. So your O&M probe and your service probe or data traffic will always follow the same route. There's no discrepancy.
Okay. Okay. Just my minor comment then. When you expand OEM, it's a maintenance. It's a operation, administration, and maintenance. Management, it's basically deemed for configuration.
Okay. Many thanks, Greg. We can make changes. Thank you.
Boris again. Could you please also add implementation section, because there are many vendors in this draft?
Oh yes, this is my bad. I should have added implementation section. There are implementation that I am aware of, so I should have added that. Thank you.
Okay, thank you. And I will also send to the list some small comments.
Thank you. Thank you very much, Boris. Look forward to your comments.
Hi, this is Dhruv. My main comment is mainly about the way you have structured things. So I see value of Spring documents when it talks in a generic sense rather than just list how to do the same thing first in via PSEP, then do the same thing in BGP. It also feels very weird to use normative language in a Spring document saying PSEP must do something like this. That's for the PSEP document to define. The beauty would be saying that it's a very generic concept in a more info model way, generic way. You can just explain what is the information that you want to pass rather than the procedures. Thank you.
You're right on. This is correct. This would be addressed. So we will address this. You're absolutely right. There should not be. This should be informational also. And yes, we will address that.
Rakesh from Cisco System, just to answer the question that Greg posed. So PM, depending on if you are monitoring the SR policy or the service that's going over the policy. So if it's monitoring the service, then it's going to use the same encapsulation as the service. But if you're monitoring the policy, then it's the same encapsulation the policy.
I think it would be very
Okay.
Yeah, but Rakesh, I think in both cases, the traffic will take the same route because you're going to the same locator.
Yeah, it's the idea for PM is that whatever you're monitoring, it carries the same encapsulation. Yeah. Thanks.
So there's no issue. Thank you.
One question. Thank you for your draft. Do you think you need a young extension? And if yes, where do you plan to do it? Either in this doc or the base doc or in another doc?
So I don't want to talk for the other like chairs, but I think overall I had a few because I did present on Monday that that idea is okay as long as there's a spring document gluing things together. Drew is here, and I think if one of the idea chair is here, they can correct me. I'm happy to be corrected. I think, but we are open. We are open either ways you like to guide us.
I'm sorry, I was referring to the young model for the SR policy. I guess you need the flag also in the young model, the one that Cameron presented.
That is correct. So I think it goes through the same comment that was made for the other eligibility. That yeah. So we should be discussed like whether we add it here or we have a second version of Yang or yeah. But if as the author, I like it to be adopted, so we can put the flag in existing Yang and done with it.
Okay, thank you.
Anyone else? Okay, thank you.
Thank you.
Amal, now we're going to talk about legibility.
Hello, I'm Amal Karboubi from Siena, and I'll be presenting updates on the eligibility draft on behalf of the authors. So before we dive into updates, just a quick recap on the draft scope. This concept of eligibility really stems from a simple observation that a path that is operationally up end-to-end and in a good forwarding state is not necessarily a path that you wanted to carry traffic. And that could be for various reasons. Any underlying network condition changes may negatively impact the forwarding quality of your path, violate your SLA. So now we have a new property. We defined a new property called eligibility at the candidate path level that acts as an additional criteria during the process of active candidate path selection. And that's in addition to the existing criteria as per RFC 9256. It's important to note that eligibility is really independent of administrative state of a path. In fact, for some use cases, it is really crucial to keep an ineligible path still up and running under the purview of some O&M measurement protocols, as this is how we can assess the health of the path end-to-end, be able to flip the eligibility back and reinstate the path to carry traffic again. Again, there could be various use cases why you may want to use this concept. Anytime, basically, you want to permit a path to be signaled operationally up, but for whatever reason, you don't want it to carry your client's traffic, you could use this concept. The draft itself does not really dictate the conditions that govern the eligibility or the components responsible for it. That is rather left to separate document or use case drafts. A few of them are using this concept already or proposing to use this concept, like optimized SID list, which uses the concept of eligibility to deal with intended path deviations when you use a loose SID list. And the other draft, flexible path selection, that focuses rather on the forwarding quality properties of a path. So it would use things like delay, jitter, frame loss, in order to define what eligibility means for them. So we presented this draft for the first time in the last IETF. The new version dealt with comments we received during the presentation and from the chats which were mainly around these key themes, component and protocol interaction. So we clarified that there is really no protocol preference or precedence. To the head end, it's really just a simple flat value. It uses the last value being set, regardless who sets it or through what protocol during the process of CP activation. We did, however, add a generic guideline for component mandate when setting and unsetting the eligibility. Again, the draft does not dictate whether a use case or a solution needs to use centralized component solution architecture or distributed one, but we did put some guidelines. Notably, there has to be a control at the component level that specifies whether this component is responsible for setting the eligibility, at what capacity, and also be aware of the conditions that govern these conditions. The conditions and the component choice, the protocol choice, are still left up to the discretion of the use case and the implementations. We also added an explicit section to re-emphasize the need to keep a candidate path operationally up for the reasons we mentioned before, which really eliminates the option of using IDR admin flags, because we were told last time, why don't we use admin flags that were introduced recently in the IDR working group. There was also various text and wording adjustment by minor one, just for clarity. So we're seeking feedback to progress this draft as a working group document. Thank you all who provided support and feedback, and if you have any further questions.
Boris Hasanov, again, MWS. Maybe I missed something, so sorry in advance. Did you evaluate the impact of having multiple CPs which could be eligible as sort of threat for device scalability or as additional impact on device scalability?
So I didn't get the question. When we have multiple candidates?
Yes, you may have multiple CPs, and they at some moment they could be all eligible.
Yeah. Then,
so device control plane have to track all those states. So you bring additional states to device control plane.
It is an additional property in addition to the ones that were defined before, the preference, operationally up, and now you add the eligibility.
I cannot agree, because previously we just had one active candidate path, and that was all. So one active, all other are backup. So now we have additional level of abstraction, eligibility, and now we on device we have to figure out like how many with eligible CPs, like who is like should be used at which moment. So if not, so please consider this also as additional like point for thinking.
To me, it's just really an additional property. Like all of them you can have all of them eligible. So it's just an additional constraint, and you still use the other RFC 9256 with the preference in order to make the tiebreaker. So only one will come as the winning candidate path.
Okay, how would you like pick up the best eligible path in this algorithm?
So the eligibility does not provide preference among the candidate path. For that, you rely on whatever RFC 9256 already defined.
So anyway, we have to use like our additional to previous constraints from RFC about SAR policy architecture. But when we just need to add this one more like constraint about eligibility.
It's just one more, exactly.
Yes, today just one more, when something else will come. So anyway, my point is what this is additional load for device control plane, and it should be like considered and at least mentioned in some sort of scalability restrictions or in documentation. Like we may support, let's say 1,000 CPs which may be eligible. I'm saying from customer point of view. You know?
I see, but like it's the same thing if you have 1,000 of them and you have the preference. So you do rely on the other tiebreaker. It's a problem that exists already.
I cannot agree again, because previously we had just one active candidate path, that's all. And somehow, like algorithmically, he was picked up and it was active, while like at least one segment list is active. Now we add additional thing, eligibility, and we now somehow have to balance, like, to consider this.
Anyway, we can take it maybe to the mailing list. I'll try to address it properly.
Himanshu Shah from Siena. So I mean, I don't necessarily agree with you. Of course, I'm the co-author on this draft, but many other people that are this has been discussed in the several working group meetings with others, as well as those who are not the authors. So it is accepted solution. It has nothing to do with the preference of which one you are going to select, whether this priority or that priority. It is just a matter of checking whether it can carry the user data traffic, because because it's meeting your intent, whatever that intent is. And there are many other use cases that are coming about. So this eligibility is important for those use cases as well. What I wanted to say, other than that, is that I think we've spent enough cycles on that. There is a wider acceptance on this, and I would strongly recommend that we progress this draft as a working group draft. So if you want to take maybe a polling here on while the people are here.
So the only thing I want to ask here is how many of you have read this draft?
Wow, 110%.
Correct. So let's take this to the list, correct? And we'll figure out the next step there. Andrew.
Andrew Stone, Nokia. Boris, I was just going to try to address the state concern. So you'd still have, take for example, without this draft, 2 candidate paths installed, 2 SID lists installed. You could still be running, let's say, BFD on those SID lists, even without this. The major difference is one of those candidate paths will go active, so that way your traffic actually gets steered into the candidate path. The major difference with this draft is that eligibility is now another criteria in that active factor, but the actual state that's installed on the device, other than checking, are you actually allowed to go active, part of that rule set, that's what really changes. Does that help a bit? Maybe. Well, we can chat after. Thanks.
Kevin.
Okay. This is Ketan Talaulikar as an individual working group member and author of 9256. The thing with the RFC is that it says that there is only one active candidate path, and that's programmed in the forwarding. There is an implicit assumption there that what is active in the forwarding is what is carrying the traffic. Switch to current date now, what we have is there is a requirement to do different kinds of measurement, qualitative, quantitative, loss, delay, how many segment leaks are up, down, and all of those things. So we are seeing a lot of those use cases coming up. And what that results is that we may need to keep candidate paths in the forwarding, evaluate them, and then when they are okay, then use it for the actual data traffic. From a control plane protocol like PSAP or BGP or whatever, what it means that they are not like failed or verification failed or invalid or anything like that. So there is the need to have something else in between, which is common, not use case specific, because there can be 100 things. So again, just inputs for the working group to discuss. I do see there is some merit in this. Thank you.
Rakesh.
Rakesh from Cisco Systems. So just from the performance measurement point of view, because you have the candidate path active, and but it's active in the control plane and you're doing the measurements, it doesn't really have to be in data plane just to do measurement. You can still do it in control.
Exactly.
Thanks.
Yes.
Okay, I got the point from Ketan, but anyway, if it's needed to keep, please test it and put it in the documentation, like how many eligible ICPs can be supported per this particular like box or this particular vendor. So customer could be like informed in advance how they can use it in practice.
Okay.
Thank you. So before we go to the next presentation, I want to ask everyone to go read a document that's going through ops area, which is called RFC 5706 BIS. Related to what Boris is talking about, he's talking about operational considerations and the need to think about how things are going to be deployed or how they're going to be operated. This 5706 BIS, again, it's an ops area, and the idea of that draft is that operational considerations will be required for all RFCs. Just like we do security considerations today, they will be required. So it is very possible that the set of drafts, individual drafts that we're working on today, will need to be published with operational considerations in them. So start thinking about that now. Better to think about things early and not at the very end that you just, lose something in there. So just a general announcement. That draft is still a draft in the ops area. It has been adopted by the area. It will be shepherded by the ops AD, but it will affect everyone in the IETF. So please keep that in mind because I know that all of us are here because we want our enhancements and extensions to be deployed, right? So it's important for us to think about how they will be used. Okay, back to the general program.
Hello.
Now we have Feng. Okay, here we go.
Hello. Can you hear me?
Yes, we can hear you. Maybe get a little bit closer.
Okay. So this is Feng Yang from China Mobile on behalf of colleagues from H3C. So today I will present the seed as source address SRv6. This proposal has been presented at the 116 IETF meeting in 2023. 2 years after 2 years of work, we have completed the code implementation and also finished the testing. So the target of this proposal is to address the security issues in the SRv6 security draft, working group draft. The first issue is bitbox filter issue that is SRv6 traffic being blocked by the stateful firewall. The second is to address unauthorized VPN access caused by packet modification attacks. So maybe just quick recap the problem. The stateful firewall in between of the head end node and the tail end node, because of the address is asymmetric address, so the traffic will be blocked by the stateful firewall. So the second problem is, so the proposal is to address the asymmetric address of the traffic. So we propose to use the VPN's SID of the local VPN for the source address. So by this way, the both of the forward and reverse traffic will have symmetric address. So the second problem is for the unauthorized access to others' VPN. If an attacker modified the seed list or destination VPN seed, for example, changing the DA from the VPN A to VPN B in this picture, the modified malicious packet will be forwarded to an unauthorized VPN. So just here is an example. If we have the attacker on PE1, if that man modified the DA of the packet from VPN A to PE2's VPN B, then the packet will still be forwarded to the VPN B, allowing PE1 to access any VPN on PE2. So the proposal to add an verification table on the tail end node. So the table will will have two fields inside the table. One is a source address. One is a destination address. As we mentioned just in the first proposal that we are using, we propose to using the source VPN address for VPN seed for the source address. And so in this table, there will be source VPN seed and destination VPN seed in this table. So if the P1 sends the packet to P2, the packet will be verified before it goes to the destination VPN. The verification table, of course, can be populated by static configuration. Also, can be done by the BGP. Since the BGP VPN seed can associated with root target. So at this moment, this solution has been verified both with H36 device and also Fiber Home's device. So at this moment, we think this solution is mature, and would like to have some feedbacks from the work group. And if there is no big open issue, we would like to have adoption call.
Sasha?
This is Sasha Weinstein. Can you please step back to, yes, what we can do with this one. This diagram seems to assumes implicitly that each VPN instantiation in HPE advertises exactly one VPN SID. But this is not mandatory to do that. It is quite, even if this is probably the, and there are varied scenarios when a given VRF, say, in the case of Layer 3 VPN, advertises multiple SIDs, say one for each of its attachment sockets with the appropriate endpoint behaviors. This will work just fine, but I suspect that it would break the idea because it is not clear to me which of these two VPN IDs you should use. VPN SIDs you should use at the source IP.
So thank you for this question. The source address should use the VPN seed as for example, if the traffic is sent out from the VPN A, it should use the VPN seed of the VPN A.
No, again, but suppose that your VPN A uses two SIDs, has two attachment sockets, and uses and advertises two SRv6 SIDs with and DX behavior for each. So this is perfectly valid. It happens. It happens say in largely within services over MPLS, or the analog behavior happens largely in IPVPN services over MPLS. So it can also happen in over SRv6 without any problem. How would the data plane select which of the two services IDs should be used as the source?
We have SRv6 tunnel, and either the cross connection or the attached circuit has those kind of traffic are carried over this SRv6 tunnel, right?
What do you mean by a SRv6 tunnel? A SRv6 tunnel, suppose for the moment that shortest path forwarding between PA and PB is good enough. VPN A advertises, as I have said, two different SIDs with end .dx behavior corresponding to two of each attachment factors, and with the common locator in the simplest case. Okay, these two SIDs are received by the VPNA and P2. How should P1 VPN and P2 decide?
So I mean, when P1 want to send the traffic to P2, it will be put the VPN seed address in the packet in the DA address, right? So for
which of them? Which of them would it say? What it sends in the okay.
So I mean, let me explain. So when the P1 want to send the P2 the traffic, the P2's VPN seed will be presented in the SRv6 packet, right? So in another way, when P2 will send the traffic to P1, it will use the P1's VPN seed, right? So in that case, we can use the VPN seed of the P1 as a source address when it sends traffic to P2.
Again, I think that there is some kind of misunderstanding. VPN, when P2 in the case
So
of
I think, Sasha, I'm sorry, I think we might want to take this to the list.
Yeah, okay.
Maybe do some drawings or something.
Yeah, maybe we can take it in the main list discussion.
Thank you. Tom.
Hi there, Fang. Tom Hill from BT. I spent quite a long time trying to understand everything about the proposal, but I think part of that issue is that some of these problems I don't think are things that if we've built our networks to the fundamentals of SR in the sense that these things are supposed to run in a trusted domain with trusted devices that you have some control over. And I'm not sure sort of the equivalent of source spoofing to either prevent or allow something is the right way to go about this. I think for the most part, if we have designed our domains appropriately, these shouldn't be problems that we have to deal with. And I think that a lot of these, particularly problem 2, I think existed with VLAN hopping. It was certainly something that we had to deal with quite a way ago. But for the most part, we shouldn't really be building these networks in a way where, for example, the destination address manipulation attack here on the slide is possible readily. I'm still very uneasy about the suggestion that we put a source address in there and effectively do some sort of source spoofing. That seems wrong. I'm willing to go back and read the draft and have a look at this presentation again, but I've got a feeling that there is maybe you've missed some fundamentals here. But thank you anyway.
Yeah, so basically that's kind of the issues has been identified in the working group draft of the SRv6 security.
Yes, there are lots of theoretical problems in there. I'm not 100% certain that this is the right way to solve those. I think we should be.
Yeah, for example, the misconfiguration, which has been already been identified 10 years ago in the 5910.
We're supposed to be automating our networks, aren't we?
Yeah.
Right. You see, this is what I mean about fundamentals. Is we should be building networks based on the security considerations draft. I don't think these are problems that need to be solved by using effectively source spoofing. But I'll cede to Dan.
The one answer to this is it's not necessarily run SRv6 just in backbone. It may be for some kind of overlay network.
Let's move on. Dan, go ahead.
Dan Voyer, Cisco. I think Tom is stealing my thunder. I couldn't agree more. So misconfiguration cannot be qualified as attack. I think you mentioned misconfigurations. And ideally, we would like to keep everything simple or simpler and leverage more automations. But again, Tom mentioned, and I would like to thumb up on this, that it's supposed to be in a control domain. We talk about that so many times. Unless this use case span different control domain, therefore it should be mentioned in the draft. But if not mentioned, then the assumption is it's a single control domain. It's a single set of architect engineers, and things should be simpler and simplify. And misconfiguration are not technically attacks.
What are you saying?
Yeah, this is Wu Jiancheng from China Mobile. I think the discussion has been some misleading. I think the main solution, the main goals of this solution is to solve a problem, a deployment problem. When you use SRv6 in a bigger network, you will might some application scenario. The traffic have to go through the firewall. At that moment, firewall will filter some traffic which is not symmetric. The address of a source and destination, if that is not matched, from the forward direction, you have a destination address and source address. When the packet go back the afterward, the address should be switched. The source address should be used as a destination address. At that moment, the firewall will filter some packet by mistake. So I think the main goal of this draft is solve those problems. The simple way is that we use the VPN seed as a source address. Then it can solve the deployment issue. That issue is bring by SRv6. So I think that is the main point. Yeah.
Thanks. So I think that the problem seems to be clear, at least to me. The objections are on the way that it is solved. So we need to discuss this a little bit more on the list and make sure that we're all on the same page on not just the problems but the solutions.
Kamran, the Cisco systems. Can you go to slide 6? I have a question, a comment about the solution slide. Yeah, so I think two questions. If VPN has more than one seat, like per CE use cases, so how does the PE1 decide which address to use as a source address? And if it does, it can use any of them. Then the egress PE, where you're maintaining the source verification table, then do you expect scalability challenges to maintaining it and cross-referencing it?
Yeah, thanks for the first question. So the egress P will set up the source verification table by the BGP. The reason is that let's think of the VPN seed. That seed has kind of VPN information, so it can be associated with the RT, road target information. So in that way, that can be can be associated with one VPN verification table. In that way, the verification table will be automatically set up.
Okay, so RT will determine what set to use. That's what you're saying.
Yeah.
Okay. Thank you.
Okay, thank you. Let's move to the next SRv6 path verification.
So this is Feng Yang from China Mobile, and on behalf of our co-authors, this solution has been presented in last meeting. We received some feedback from mail list, primarily from Antoine. Thanks for Antoine for a discussion. And SRv6 path verification aims to address issues mentioned in the working group draft of the security working group draft, such as modification to the SRH, like including additions and deletions or injections of packets with SRH as intermediate hops along the path. So, sorry. So let's quick recap this issue. If a captured user packet is injected as intermediate hop P2, since each HMAC is valid, neither P3 nor the tail node can detect this attack, and the malicious packet will be successfully forwarded to the destination. So the proposal is can be illustrated by this diagram. The simple topology illustrates the path verification process. The controller configures the SRv6 policy on the header node and the verification information on the tail end node. Considering that FRR protection may cause expected path changes, the tail node needs multiple sets of verification information, one for the primary path and one for the backup path. For clarity, only one set is described in this diagram. The TLV in this diagram is newly defined path verification TLV. Though reusing the SRH HMAC TLV is also an option. Here, the ALG means algorithm. It can be regarded as HMAC algorithm, and ALG sub n denotes the HMAC with a key equal to key n. the DA refers to the destination. So in last version, uh, our uh, our method requires two input parameters. The first was the packet's DA at each hop. We calculated ARG sub n of DA. The second was value in the packet's TRV, which was not subject to additional operations. So the output of ARG sub n of DA and the TRV value was directly summed up to update the packet's TRV. So this process will happen on each node, each hop. So resulting in verification information that was linear combination of all of the ARG of DA values. However, this this method will have some problem. It will only verify whether the packet passed through the set of nodes in the seed list, but could not tell if the path order is correct. In the updated version, we use a recursive ARG approach as illustrated in this diagram. The overall process remains similar. The main difference is in that the calculation of the ARG sub n as the second and subsequent nodes. For example, at the node P1, we calculate ARG sub n of TRV instead of directly using the TRV value as to sum up to sum up with ARG sub of ARG sub n of DA. So this is kind of the recursive calculation. This will be repeated as each subsequent hop, generating a verification value that includes both of the forwarding nodes and their orders. By comparing these values with the expected value as a tail node, we can determine if the actual forwarding path has been modified or not. There are two advantages. First, the packet overhead of this method, like the HMAC method in RFC 8754, is a constant value that does not change with path length. Second, the computational loss is constant as well. As calculations are only performed on the TRV value and DA using ARG sub n, make it easier for the GPU implementation. So that's all. So, by the way, we have received the email reminder from IENA stating that the reservation of the TRV code should be marked as TBD. We will update this in the next version. So thank you.
Comments? Anyone? Questions? Okay, so I guess we need to move forward, discuss this more on the list. Thank you, Feng. Andrew, you are the last one.
Okay, hello everybody. I realize it's the last slot, so hopefully this will go pretty quickly. Presenting on behalf of myself and Pavan, and I'm here to talk about multipath traffic engineering for segment routing. Hopefully everybody's kind of seen some of the presentations that Creedy has been doing, the TS working group in the last IETF. Essentially last IETF, he introduced this concept of multipath traffic engineering. So really what it is, it's a traffic engineered tunnel where you're intermixing the benefits of both ECMP, non-ECMP, traffic engineering, and even this concept of slack. So really it means shortest path with some slack, right? If you've got a path that's 60 milliseconds long, who cares if it's 65 milliseconds is also an alternative path. And so really the outcome of this is that you end up signaling a DAG, a directed acyclical graph. So you're no longer signaling just one path or a collection of paths. You're essentially signaling an entire graph as part of your transport tunnel. And as part of that specification, the DAG can be either centrally computed or it can be distributed, right, based off of some other drafts that are associated. So what I'm here to talk about today is how I think you can do this with segment routing and a central controller. So in principle, the DAG, the graph, is computed and signaled by the controller, or PCE, right? Your loose terms, however you want to implement that. The DAG, the directed graph, is comprised of a collection of junction nodes. And the general idea is that we're introducing this concept called a junction segment. And a junction segment is deployed on a junction node. So for example, hopefully the graph is big enough. You can see node A in this diagram is an ingress node. So an ingress node would get an SR policy, like usual. The path set, or the SID list that would be actually signaled to that node, all it's doing is it's carrying an SR path to the next junction node. So in this diagram, you can see node C, for example, is a junction node. There's multiple outgoing interfaces, multiple outgoing paths, which go then beyond that throughout the rest of the DAG. And on node C, what you're doing is you're installing the junction segment. And the junction segment itself is comprised of a binding SID. So again, these are all constructs that already exist in segment routing today. So from A's perspective, here's another example of it. From A's perspective, it's just a regular SR policy with two SID lists. The SID list defines the path to the next node that it wants to have performing the junctions. So for example, C. And on C, it receives a junction segment. Oh, I'm going to jump ahead over blue. So if you look at the green box, junction segment C has a binding SID. So A takes a path to reach C. That packet, the segment routing encapsulated packet, contains the binding SID to C. And at that point, C now branches the traffic. So the idea is this entire graph that you're signaling is comprised of a bunch of little binding SIDs, sprinkled throughout the topology to actually achieve the graph. And when you signal that junction segment, the outgoing SID lists also contain their own weight. So no longer is it just doing ECMP on the ingress side, you can also do weighted, controlled, each individual junction segment throughout the graph. So you can imagine on a fairly large topology, you can end up with a significant amount of paths. Now the obvious question is, why don't you just use segmentless on the ingress? Absolutely. If your graph has only a handful of paths, or you compute a DAG that can be represented by a small subset of paths, 100% use the SID list on the ingress. However, there are some graphs and some topologies where you can really start to expand the number of paths that are traffic engineered, right? ECMP, non-ECMP, spreading away from the shortest path, where that count of paths starts to increase significantly to the point where it might not make sense to actually signal to the ingress. For example, you probably don't want to have an SR policy on the ingress that has, for example, 40 SID lists. But in a DAG, it's quite feasible to actually achieve something like that with relatively minimal overhead in the encoding. So how do you actually program a junction segment, right? I mentioned a junction segment has a binding SID and outgoing SID list. Well, it's an SR policy in itself. So what the draft is proposing is signal a SR policy to node C in this example. It has an endpoint, it has a color. Well, we need to plug in a color value. Let's plug in the value that actually represents the DAG, the directed path, or sorry, the DAG, the DAG identifier. Otherwise, everything else remains basically the same. Something I didn't point out on the previous slide, actually, that I just thought about to mention, these junction segments don't have to be deployed on every node in the DAG. It can still rely on your regular segment routing constructs. So for example, in this example, B is programmed with a junction segment, and you can see B, its SID list is the node SID of H. So even though I've got E as a transit node in the DAG, we don't actually need to install a junction segment on it because there's only one outgoing SID list. So you gain some optimal placement where you don't have to install these binding SIDs throughout the network, but every time you branch to more than one outgoing interface, that's where you end up with a junction segment. Nice kind of property again. Again, this is all normal segment routing constructs. We can then take this DAG and apply a binding SID even on the ingress into the DAG and build hierarchy. So you can imagine in certain topologies, it's quite useful to say, we're going to set up a DAG somewhere in the network. It's going to use a lot of paths, and things upstream from that DAG can now reuse that DAG that was just instantiated. And so there's probably a question in the room that's, why is the document standards track as opposed to an informational track? Correct. It does not define anything new at the moment. At the moment. There's still some thought that has to be put into how do you do optimization, whether it's local optimization, global optimization. The use of the color field, on one hand, it seems sensible to install the DAG identifier in the color field. On the other hand, it's kind of abusing the purpose of the color field. So I think as a working group, we probably need to decide, is this use of SR policies on these junction nodes actually suitable for what we want to achieve? Because if we do that, we don't have to do any new extensions for that purpose. So the next steps really just kind of open for discussions, feedback, collaboration. Really the draft is an initial version 00 state. Obviously as the multi-path traffic engineering draft introduces new concepts or bring in new requirements, this draft will have to stay aligned with that. Like I mentioned, the use of the color field, whether that's acceptable, we've got to decide on that. And then there is some gaps in the draft as it is to discuss how you would do local optimization and global optimization. And on that topic very quickly about local and global optimization, if you think about the DAG, once you compute this DAG, it's probably going to be very unlikely that you actually need to re-optimize the DAG. And what I mean by that is adding or removing nodes from the DAG. Once the DAG has been calculated, we push it down. And yes, things like link failures and node failures have to be dealt with, but it's not like you're doing a path optimization or a DAG optimization very frequently. There could be situations where maybe you do want to completely recompute the DAG in a full make before break kind of solution. Those types of steps and procedures and what does that signal look like, that's the kind of stuff that has to be explored. Now, jump ahead back to here. And yeah, that's everything. That's the end of the slide. So any questions, comments, feel free.
Zafar, Cisco Systems. Thanks, Andrew. You just showed that NPT is already supported in SR. And more importantly, it's supported by SR MPLS and SRv6. I think this doesn't come to me surprise because the core idea about NPT, about WECMP or ECMP is in SR from day one. So it doesn't surprise me. I like to highlight that there are other APIs like GDB and other API that also achieve the same purpose of building such trees in the network. So that's citing. One specific comment I have for you when you have the question about the color, you have a slide where you put the color. So this DAG ID is something which is the application aspect. Color in segment routing policy architecture is intent. So say for instance, you have an intent which is encoded because of some metric and some constraints, and together that gives you indicator that which transit policies you can reuse for other transit policies purposes. So I am completely against using anything for color. In reality, DAG is a construct that can map to binding set, and that mapping is local to the application, not something the network needs to worry about. That would be the comment, which means really zero change. And transit policies, SR already covers this whole thing because of the ECMP and WSMP concept from day one.
Can I just, before you go to the next thing, just the previous comment and this one, so I'll address this one really quickly. So are you recommending to plug something else into color?
Color is the intent. So why you computed that policy is the reason, and that is encoded in color. So you have
I agree with you. The concern that I have is that color is also used for head-end steering. And so on this transit junction node, I actually don't want to have anything steered into this. Its whole purpose is for the binding SID, right? The color is actually mostly irrelevant. I don't really need to use the color. I don't want to use the color.
So you computed a path.
I computed a DAG.
You computed a DAG. Okay, that DAG has an optimization, reason, and constraints. That is the intent. And that is applicable to the head end that is using that policy, transit, and it's applicable to any transit policy that you cascade.
Yes.
So that's why this becomes an end-to-end intent, and you can reuse it. You can reuse for other policies
yep, I
that are
agree.
the same intent, right? You can use transit policy with the same intent. So that also gives you, the color gives you indicator that you can reuse, what you can reuse, what you cannot reuse. And anyway, the architecture wise, this is an application construct. Yeah, like I mentioned, is really the diag to binding set mapping.
And just to address your previous point, are you suggesting to also list another protocol that a controller could use? Or are you suggesting something else? I kind of missed what.
No. I'm not suggesting. I think you already showed that there's zero change needed.
No, I mean, you mentioned on your previous comment that I didn't quite catch all the details of it, that there was another protocol that could use something related to an API.
No.
So
That's a completely orthogonal to IETF discussion, but this is GDB,
Yeah,
which is
okay.
which is the API
So
to.
we have, if it's a complete different discussion, let's have it somewhere else. We have about 5 minutes left. 3 other people in the queue, so please wrap it up.
Okay.
Thank you.
All right, we'll chat about your third one after, I guess.
Himanshu from Siena. I think we had this discussion in the hallway. Just wanted to bring it up because some other people may have the same question. I think in this model and this whole thing about SPF based and default forwarding scenario in the ECMP is that the network is utilized based on the fact that there are multiple traffic sources. So if there are, in your diagram here, if you had a source, a traffic source at D, G, B, E, C, F, and everyone doing this, right? Then you are not, all those links are congested and you will not be able to take advantage of the network paths that you previously thought are not utilized, and you can use the UCMP and distribute the traffic. So I think that may be something to consider. Maybe this is something done only for certain cases, this traffic steering.
Yeah. It's not like
for
if,
all.
If you have a ring topology, you're not going to do
Yeah,
this.
exactly. The
Right?
ring
As
topology
a
is
simple
not gonna
example,
work.
there's no
Yeah.
gains there. There's no benefits there. So it really will be use case dependent, topology dependent, where your ingress and egresses are. It's very much, here's another tool in the toolbox that we can kind of
Yes,
apply
yeah.
to build these kind of solutions.
Right. Okay.
Thanks.
Hey, Andrew. Kiriti here. You had that thing with the binding set and the 0.6 and the 0.4.
This one? Or
Yeah, this one. So is that a construct that's already there, that you can say, I want this SID list and I can do a non-equal load balancing across that?
In the SR policy architecture, in the information model, yes. What is missing, and this is one of those things where it's standard versus informational, is the concept of weight zero. Weight zero is missing.
Oh, okay. But non-zero weights are there.
Correct. Yeah.
Okay. So that's the only thing that you might want to standardize.
Yeah. So this is what I mean by staying in sync with the architecture document. Weight zero is quite useful in these kind of DAG situations. So maybe we do need to introduce the concept of weight zero inside of SR policy's information model.
Cool. Thanks.
Nitzan from Ribbon. Just having Kiriti here. This brings me to his proposal in the TIS work group. So I wondered, just the high-level questions. I mean, which is better? I mean, he also presented just a high-level question.
Yeah, so Creedy's presentation actually had 2 parts. One of them was the high-level concept of a DAG, and this is still applicable to that. It's the same thing. We're computing a DAG. The second part of Creedy's presentation in TIS was to do signaling with RSVP.
Yeah,
as opposed to this signaling is, well, we're going to use, and in the data plane, it was RSVP MPLS, whereas here the data plane is segment routing. We're not going to use RSVP for segment routing. We're going to use segment routing. And so in here, it's more of a controller-oriented solution. But the end result is you still get a DAG, and the whole goal is to spread traffic around, do bandwidth balancing, right? All the nice, lovely list of things on this slide, right? Traffic engineer constraints, DCMP paths, non-ECMP paths, it's still part of that solution. So if you want to think of it from an inheritance or a branching, there's the MPT construct. One way is to do with RSVP. One way is being proposed here.
Great. Thank you so much, Andrew. So we finished 1 minute early. Just a reminder, we will have probably 2 interns between now and the next IETF, one focused on security and the other one on SR and NRP. Please stay tuned for that. Thank you so much, and we'll see you at those interims.
Oh, and you're still willing